So now let's talk about evaluating trigonometric functions. It says there are two ways to evaluate a trigonometric function: decimal approximations with a calculator and exact values using trigonometric identities and formulas from geometry. So in all honesty though, the TI-30XS does an amazing job at giving you the exact values. For instance, root 2 over 2 is a value you will commonly see. That's for the 45 degrees or the pi over 4 angle. Our calculator does a really good job of giving us that root 2 over 2 as a final answer instead of giving you the decimal version of the answer. And if you look on your calculator above the enter key, on the bottom right is a double arrow looking key that face opposite directions. That's going to be one of your best friends this semester. Anytime you see a decimal and you want an exact or fraction value, or vice versa, if you're given the fraction and you want the decimal, you just hit that double arrow button above the enter key on your calculator. That will really help you out. So it says, when using a calculator to evaluate a trigonometric function, remember to set the calculator to the appropriate mode. I always keep my calculator in radian mode. Always keep it in radian mode, and then anytime I want to enter a degree, I just hit that second PRB button for angle, and then I hit enter for the degree. So as long as it's in the radian mode and I put that degree symbol there, it'll work for both degrees and for radians. So always in radian mode for me. It says you should have memorized the two triangles in the unit circle to help you evaluate trigonometric function at a given angle in the unit circle in both radians and degrees. So what we're given here is the radian measure of each one of those. I'll draw the similar ones that are in the degree measure. So the pi over 4 is the same thing as 45 degrees. So this is the 45, 45. Let me put the degree symbols. And then you have your 90 degrees, that right angle with the box. And that's a 1, 1, and a root 2. And what this allows you to do is say, for instance, the sine of theta. If you remember the sine of theta, so is opposite over hypotenuse. So what's the sine of 45 degrees? If you know this triangle and you're looking, here's a 45 degree measure angle. It would be the opposite, which is 1 over the hypotenuse, which is root 2. So this would be 1 over root 2, 1 over square root 2. And then to rationalize the denominator, you had to multiply the top and bottom times the square root of 2 over square root of 2. Remember, we're just multiplying by the number 1 here, which you would end up with the value of root 2 over 2. So these triangles, if you know SOHCAHTOA, you know cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. And just sine flipped, cosine flipped, and tangent flipped, right? If you know that and you know these triangles, you could find the values of every single one of these angles that we care about on the unit circle. Same thing here, we have pi over 6 and pi over 3. If you remember what's the degree measure of these two, pi over 6 was 30 degrees and pi over 3 is a 60 degrees. So this was your 30, 60, 90 triangle. The longest side is a 2. That's the hypotenuse, sorry. The longest of the two sides is the square root of 3, and the opposite side is a 1. So for instance, if I wanted to find the, let's do, how about the tangent of 30 degrees? Well, if you remember, tangent is TOA, so that would be the opposite over the adjacent. So I take a look at 30 degrees, I look at the opposite, which would be a 1. I look at the adjacent, not the hypotenuse, the adjacent, which would be a square root 3. I need to rationalize the denominator, so that would be a root, multiply it times root 3 over root 3. Again, just multiplying by the number 1, not changing the value. And I'd end up with the tangent of 30 degrees is root 3 over 3. And so go ahead and try that in your calculator. I want you to hit tangent, and then I want you to hit 3, 0. And then remember, if you're in radian modes, you need to hit second PRB, enter to get the degree symbol, and hit enter. And the beautiful thing is our calculator actually gives you square root 3 over 3. Many calculators would not have given you the square root 3 over 3. They would have given you the decimal approximation. Again, to see that decimal approximation, all you have to do is hit the button on your calculator that looks like two arrows facing opposite directions. It's right above the enter sign, and it'll give you that decimal approximation. So there's about 0.577. So most calculators would have given you that 0.577 decimal. It goes on forever. but most calculators would have given you that number. Our calculator's nice enough to give us the exact value. Okay, so what's the idea? Trig teachers like you to remember these two triangles because these give you all of the angles necessary for the first quadrant. So let's look at the first quadrant. Remember, this is the first quadrant here. Okay, the first quadrant is positive x values, positive y values. Again, if you look at this unit circle, it's going to give you both the degree and the radian. We went through this earlier in the packet, so I'm not going to go through those again. But the nice thing is it gives you the sine and cosine values. If you notice, this is called the unit circle because the radius is 1. And if you remember, cosine of theta was x over r, sine of theta was y over r, and then tangent theta was y over x. Okay, and the r here being the radius of the circle. Well, the radius of the circle here is 1, so it's really, really nice for us. So for instance, let me show you how they got some of these values. I want to look at 30 degrees. So here's a measure of 30 degrees. If you imagine that we dropped a triangle right here, this would be our 30, 60, 90 degree triangle right here, right? And we know that the hypotenuse here is 1. Well, go up and look at that triangle that we got above it. It's not exactly the same because our hypotenuse in that 30, 60, 90 triangle was a 2. But you could do the same thing here and you could figure it out. What you're telling me, here my x value, my hypotenuse is 1, so that's the longest of the two. My x value is the root 3 over 2, and my y value here would be the 1/2. And all you did to get this is you took all the lengths of the sides of the triangles and you divided them by 2. So take that triangle that we had in the picture above, we divided all of those lengths by 2. Really nice, convenient there for you. You can see that the root 3 turned into root 3 over 2, the 1 turned into 1/2, and the 2 turned into a 1. But the nice thing here is you learn that cosine theta, which is x over r, or just the x value here, is root 3 over 2. The y value, sine of theta, is the y value here, which would be 1/2. I also want you to notice the decimal approximations. If I say what is root 3 over 2, I want you to find the decimal approximation for that. So go ahead and do that now. I'm going to hit n over d. I'm going to hit the x squared button for the square root of 3 over 2. I hit enter, and again it tells me root 3 over 2. So I hit the double arrow button, which is going to give me the decimal approximation, which is approximately 0.867. If you see that decimal, that's the approximation of root 3 over 2. And I also want you, well, I know what 1/2 is. 1/2 is equal to, we don't even need approximate, so it's 0.5. So what I wanted to emphasize here is that 1 is the hypotenuse. The hypotenuse is always the biggest of the three values. Root 3 over 2 is bigger than 1/2. That's really what I want you to notice. Because if you look at this triangle, the x value of this triangle is larger, the y value is smaller. Root 3 over 2 is always paired with 1/2. Root 3 over 2 is always the larger of the two values. 1/2 is always the smaller of these two values. Why does that matter? Let me draw another triangle here. I'm going to draw it for this 60-degree angle. I'm going to drop it straight down. Here's my right triangle, so I'm drawing this one in red. So here's my 60-degree angle, 60, 30, 90. And if you notice here, look at this. Do you see that the x value is certainly smaller than the y value? So that means that x value here of that triangle would be 1/2. The y value of that triangle would be root 3 over 2. So I always think about which one goes first, root 3 over 2 or 1/2. Which one goes where? Well, just look at the x value. Think about where is it? Is it closer to the y-axis or is it closer to the x-axis? If it's closer to the y-axis, then the y value is root 3 over 2. If it's closer to the x-axis, then the x value is root 3 over 2. So it's always which one do you have there. And then the nice thing, the beautiful thing is if we look directly in the middle, that's our 45, 45, 90 triangle, and that both your x and y values are the same. So that's the root 2 over 2 and the root 2 over 2. So again, in the middles are always going to be root 2 over 2, root 2 over 2. For the other 2 points, the pi over 6, the pi's over 3's, you're going to have a root 3 over 2 and a 1/2. Root 3 over 2 being whichever axis it's closer to. If it's closer to the y-axis, then it's root 3 over 2 is the y value. If it's closer to the x-axis, root 3 over 2 is the x value. Okay, some other things that students notice. If as you move from left to right, from the y-axis, look at this. Look at the numerators. All the denominators are 2 in every single one of these values. And then it goes 1, root 2, root 3 as I move to the right. My y values as I go up go 1, root 2, root 3. So x values get larger as I go to the right. Y values get larger as I go up. Okay? So that's just little things to help you. Why do I care about this? Because if you know the first quadrant, you now know every single quadrant. Okay, in that first quadrant, you know that both x is positive and y is positive. That means that cosine is positive, sine is positive, tangent is positive, secant is positive, cosecant is positive, and cotangent is positive. All of these are positive values in the first quadrant. Well, how do you find everything in the second quadrant? Let's move on to the second quadrant now. To find the second quadrant, what I can't do is I can't help you with the angles right now. You have to know your angles. So you have to know the 2 pi over 3, the 3 pi over 4, the 5 pi over 6. We did the angles earlier. What I'm talking about is your trigonometric values at those angles. So what I want you to do is realize, again, all of our denominators are square root, or 2's. All of our denominators are 2. As I go further to the left, I go 1, root 2, root 3. And as I go further up, I go 1, root 2, root 3. So that's the exact same thing here. And if you look, there's something called symmetry. Symmetry is like a mirror, right? That y-axis is our mirror here. Here's the point 1/2 root 3 over 2. If I flip it over, it's still 1/2 root 3 over 2. But what's the only difference between the two of them? In quadrant 2, your x values are negative. Sorry, let me rewrite that. Your x values are negative, and your y values are positive. Your x values are negative and your y values stay positive. So the y values stay exactly the same. Our x values are exactly the same, but the negative versions of them. So if x is negative, that tells me what's negative would be cosine. That would also force tangent to be negative. That would also force secant to be negative, and cosecant would be negative. Which ones are positive? Well, that would be sine, the y values, and cosecant, which is the reciprocal of sine. Look into quadrant 3. Quadrant 3, what have we done? Well, we've taken everything from the first quadrant and we flipped it over the origin. So take the exact values and make the x's and the y values both negative. So both x and y are negative in quadrant 3. Let me go ahead and write that down. X values are negative and the y values are negative. So what does that mean? Which functions are positive and which functions are negative? Well, x is cosine, so cosine is positive, cosine has to be negative because my x values are negative, which also means secant is negative. Y values are negative, which means my sine is negative. And then cosecant would also have to be negative because that's the reciprocal of sine. But then tangent is sine over cosine, or y over x, which would be a negative over a negative, which would be positive. So tangent would be positive. Cotangent would also be positive in this angles. Okay? Again, I want you to remember your pi over 6's. Pi over 6's are always closer to the x-axis. Pi's over 6's are always closer to the x-axis. Pi's over 3 are always closer to the y-axis. So be careful with those. Pi over 4's are always in the middle. Pi over 6's closest to the x-axis. Pi over 3's are closer to the y-axis. Pi over 4's are in the middle. You still have your root 2's over 2's paired in the middle. You just have both of them are negative. You still have your 1/2's and your root 3's over 2 paired together. Again, the root 3's over 2 are the x values when it's closer to the x-axis. The root 3 over 2's are the y values when it's closer to the y-axis. So you know which order to put them in. You know to label them all as positives and negatives. Same exact argument here in the last, which is 4, quadrant 4. When you're looking in quadrant 4, your x values are positive. Your y values have to be negative. Remember your x values being positive, so let's think about which functions are positive. X represents cosine, so cosine would be positive. We know if cosine is positive, then secant has to be positive. Think about which ones have to be negative. Your y values are negative. That tells you y is sine, so your sine is negative, which also means your cosecant has to be negative. Tangent is sine over cosine, or y over x, so that would be a negative over a positive. A negative over a positive is negative, so we know that my tangent values are negative and that my cotangent values are negative in that quadrant. Okay, so the unit circle, really all you have to know is quadrant 1, and then you just have to make, in quadrant 2, same exact values, just make the x values negative. In quadrant 3, all values are negative, both x's and y's. In quadrant 4, your x values are positive, but your y values are negative. It's always root 2's over 2's paired together in the middles. It's root 3's over 2's for the y values closer to the y-axis. It's root 3's over 2's for the x values closer to the x-axis. The pi's over 6's are closer to the x-axis. The pi's over 3 are closer to the y-axis. If you know these kind of rules, this is really, really going to help you out in memorizing the unit circle. What's the idea on the test? Can you use your calculator? Yes. So technically, do you need to memorize this? Well, not necessarily, but we are going to have you graph things into graph things. It helps a lot if you know the values. To evaluate these functions faster, it helps a lot to know these values. So I highly, highly, highly recommend remembering the unit circle. When I teach a trigonometry class, I do multiple tests on the unit circle. Every one of my students are required to label every single angle in both degrees and radians, and every single one of those points in 5 minutes or less.